So the first integral that we have is the integral 1 over x to the 2021, of course to the year of 2021, and then we are going to add the x to it. Usually, we only factor out the x to the smaller power, but here, if you are willing to factor out x to the bigger power, namely x to the 2021, then this right here will be very, very nice, and you end up with 1 plus x to the 2020, but it will be negative, right? So now this will be the new denominator, and this is going to be so nice. Have a look right here. Here becomes the integral, and then we are going to keep this on the bottom. So we have 1 plus x to the negative 2020th power. And then we will see that this right here, we can bring that to the numerator, and we will just get x, but you make that into a negative exponent, namely negative 2021. And do we see it? Hopefully we do. Because right now we can just do u-sub, let u equal to the bottom, let u equal to 1 plus x to the negative 2020. And then we are just going to do the usual business. You see that du is just going to be, we get negative 2020, and we get x to the negative 2021 dx. And I'm going to isolate the dx, so you will see that dx is equal to this guy, right? Du over this guy, negative 2020 x to the negative 2021. And of course, now let's take this integral to the u world. We will see that this becomes the integral, and let me just keep that on the top, x to the negative 2021 over the bottom is just our u. And then the dx is just that, so we have du over negative 2020 x to the negative 2021. I like to do it this way because I like to show the cancellations. So you see this and that cancel, and you can see that exactly what we need. This right here, we have the negative 2020 on the bottom. So we're going to write that down first. We have negative 1 over 2020. And then we just have to integrate 1 over u in the u world, which we get ln u, but u is equal to what? This guy. So we're just going to put that down. 1 plus x to the negative 2020. And this guy is always positive, so you don't need the absolute value. We can just put down a parentheses. And I just realized I ran out of space to put on the plus c. So I'm just going to put on a plus c right here and make it pretty big. So this right here is the first one. And the truth is, whenever you have x to some power here, and then plus x to the first, you can always do that. For this one right here, we can do partial fractions right away because this right here is not a rational function. Because for a rational function, we must make sure that we have x to some positive whole number power. This is technically x to the 1/2, right? Here's the little thing that you can keep in mind. Whenever you have an expression that involves square root, just go ahead and do a u-sub and see what happens. So I'm going to take a u-sub, let u equal to square root of x. And then you will see that square both sides, we get x equals u squared, and then differentiate both sides, we get dx equals 2u du. And this is going to work out very nice. You will see that this becomes the integral. On the top, we have 1. On the bottom, x is the u squared. And then plus, here we have the 3, and the square root of x is the u. And then we have the plus 2. And then we have the dx being 2u du. So allow me to put this down right here. We have the 2u here, and then the du here. And that is very nice. Now we can do the partial fraction. Because I don't think there's any way to avoid partial fractions for this. To do so, I'm going to factor the bottom, and this right here is pretty nice. It's just u plus 1 times u plus 2. And then you can see that, and again, I should have mentioned that because the degree on the top is just 1, and the degree on the bottom is 2, you can do the following. If the degree on the top and on the bottom are equal, then you will have to do long division. So we are going to go ahead and proceed. Here we have the integral, and then we are going to just have 2 fractions now, because I'm going to do the partial fraction right here. For the first fraction, we will have u plus 1 on the bottom, and for the second fraction, we will have u plus 2 on the bottom. Now, this is my favorite way to do partial fraction, and works for this kind so well. The cover up method. So This right here, it's going to be a number because the bottom is just linear, right? And they have distinct factors. So what we are going to do is go back to the original here, and we are going to cover up the same denominator, and we have to ask ourselves, how can we make u plus 1 being 0? Well, u has to be -1. Then we are going to put -1 in here and here. So you can just do this in our head. So 2 times -1 is -2. And then -1 plus 2 is 1. So we have just -2 pretty much. But let me just put it as -2 over 1. Now, don't worry, we have another chance to practice that. To figure out this number, well, you go back to the original and you cover up the same denominator. And you are going to plug in the number that can make this factor equal to 0, which is -2. So you're going to use u is equal to -2, put in here and put in there. So 2 times -2 is -4 over -2 plus 1, we get -1. So altogether you will just get +4. So right here, this is -2 and then absolute ln, and then we put down parentheses, u is square root of x, and then we put down +1. And then this is going to be +4, and then integrate the u plus 2 on the bottom. We get ln, u is square root of x, and then we add 2 to it. Absolute value is not needed, so just parentheses, and then in the end, put down the plus c. This right here is it, right? So it's not so bad. Partial fractions for this x to the 4th power plus 1, it's pretty hard to factor. It's factorable, but it's pretty hard to factor. So here's the deal. We are going to divide, which is the same as multiply by 1 over x squared, right? So let's see what will happen. And this is going to work out very nicely, you will see. Well, and you also have to do some completing a square in the following way, right? So let me show you. Here, this right here is just 1, and then we have 1 over x squared, and then of course this times this is x squared, and this times this is plus 1 over x squared. All right, that's pretty nice, because this is actually almost a perfect square. And let me just put that down for everybody so you can see what's going on the bottom much better. So let's just make an observation, OBS. Right here, when we have x squared plus 1 over x squared. Technically, let's look at it like this. For the x squared, which is the same as saying x to the 2nd power, and then the 1 over x is like this, 1 over x to the 2nd power. This is almost a perfect square if we have something in the middle. So what do we want to do? And the reason that we want to do this is because on the top, this is also going to be pretty nice. Have a look. We have 1 plus 1 over x squared. Well, what we are going to add here is that we are actually going to have minus 2ab, because this is a squared and this is b squared already. If in the middle we have minus 2ab, which is just 2 times x times 1 over x, then this becomes a perfect square. You can also put down plus 2ab plus 2 times x times 1 over x. That will also complete the square as well. However, you will see that for this part, this is going to give us what we really want. This becomes x, and then because of the minus here, it's a minus here, and then we have 1 over x like so. The reason we want to do this is because we can then just do a u sub, let u equal to x minus 1 over x, and the differentiation for this is just going to be what we have on the top, and that's going to work out very nicely. Of course, we cannot just subtract the 2x minus 1 of x out of nowhere. It's okay. All we have to do is just go ahead and add this at the end. So I will put down plus 2 times x and then multiply by 1 over x. But this is really just a plus 2. So that's what we have on the bottom. And let's just go ahead and put that down here. So I'm just going to bring all this over there. So what we are going to do is, technically, we're just going to put down plus 2 and then minus 2. And we will see this becomes the integral. On the top is still 1 plus 1 over x squared over this guy is just going to be this guy. So I'm going to write it down. x minus 1 over x, and then square, and then and then plus the 2. So let's put that down. And then we still have the dx right here. Right here, we are going to do a u-sub. I'll just put a u right here. Let u equal to the inside, which is x minus 1 over x. And then differentiate that real quick. We get du just being equal to 1. And the derivative of 1 over x is negative 1 over x squared. Negative times a negative gives us the positive, and then we have the 1 over x squared, and then the dx. And see, that's exactly what we have on the top. That's why earlier we chose to minus instead of plus, so that this works out very nicely. All right, then what's going to be is the integral. This altogether is just our du, so I'm just going to put that on the side, and we will just have 1 over, this is just the u, and we have that square, and then the 2. Because right here we have plus, so you know we are going to use the arctangent formula, so put down square root of 2, square, and then the du right there, right? So now let's go ahead and just finish this. To integrate 1 over u squared plus a number square, it's going to be 1 over this number, which is square root of 2, and then multiply this by the inverse tangent of u, and u is equal to this, so I'm going to write that down right here, x minus 1 over x. Right, this is the u, and then we have to divide it by the a, which is the square root of 2. And let me just write it down right here, 1 over square root of 2, like that. So that will be the input. And altogether, this is it. So of course, put on the plus c. That is it. You know how to do this one? Just do it. No tricks, no gimmicks. Just straightforward partial fractions, completing a square, and lots of work. Hopefully I can finish everything on this whiteboard, but we will see. All right, here we go. We are going to factor this guy. This is the sum of 2 cubes. It's not so bad. The formula is just going to give you x plus 1 times x squared minus x, and then plus 1 squared, which is just 1. So that's the factoring for that. Now, we are going to do the partial fraction on the side. So you see that we have 1 over that for the denominator. So we have x plus 1 times x squared minus x plus 1. And then break this down into 2 fractions. The first one will have just a constant on the top. So I'm going to put that as a. And then over that. And then next we have this as the denominator, which is x squared minus x plus 1. But this right here is an irreducible quadratic. So on the top, we must have a linear. So we put down bx plus c. Good news. We can use the carve-out method for a. Bad news. That's the only one we can do. Anyway, let's go ahead and find out what a is. So to find out a, you see, we have x plus 1. We go back to the original, and then we cover the same denominator, and we just have to make sure that x becomes negative 1. And then we're just going to put it here and here. So this time we'll show you guys the word. We get 1 over, we get negative 1 squared minus negative 1, and then plus 1. Work that out, we get 1/3. So that's what a is. A is equal to positive 1/3. Okay, fractions time, of course. Now, to solve for b and c, from my experience, I think the students are more okay to do the following way. You can also just let x equal to like 0 or like 2 or 1 and then plug in and then just solve for the b or c. But the following way, I think it's straightforward, and then more students are okay with this right here. So I'm going to do that. All right, so I'm going to multiply everybody by the lowest common denominator, which is just this and that. So on the left-hand side, we will get 1. And then because a is equal to 1/3 already, so that's good. Imagine we multiply everybody by this. Then x plus 1 cancel. So we just have to multiply the a value with that, which is 1/3 times x squared minus x plus 1. And then we are going to just write this down plus bx plus c. This will cancel, but we have to multiply that with x plus 1. And then again, just do it. just do it. So this right here is going to give us 1/3 x squared minus 1/3 x plus 1/3. And then multiply this out, we get plus bx squared. And then let's do bx plus 1, which is plus bx. And then plus cx. And then lastly plus c. Oh, such a long expression, huh? All right, you don't really have to continue that much. Pay attention to the x squared term, which is this and that. You can see that we get 1/3 plus b, and then we can factor out the x squared. So that's the only x squared terms that we have right here, right? But on the left-hand side, we don't have any x squared term. So what does that mean? That means this guy has to be equal to 0. So right here, we know that 1/3 plus b has to be equal to 0. Thus, we know b is equal to negative 1/3. Pretty good. And then we just have to find out c. You don't have to collect the other terms if you don't want to, because there was 3 things to do. So I'm just going to put down da 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 and then x. And then you will see that here we have 1/3. Here we have c. These are the constant terms. On the left-hand side, we have 1. On the right-hand side, we have 1/3 plus c. So that means 1/3 plus c has to be equal to 1. And then do your little fractions. C is equal to positive 2/3. So that's pretty much it for the partial fraction part. Not the integral. We are not doing anything with the integral yet. So cannot be too happy at the moment. All right, so that's the partial fraction. Now I'm going to go back and I'm just going to put down what we have. So right here, first, we are going to break this down. The first fraction is 1/3 and x plus 1 on the bottom. So I'm going to put down the 1/3 in the front. And then we are just going to focus on the integral and then 1 over x plus 1. And let's close that. Next, we have the bx plus c. And the b is this and the c is that. Well, notice that they have the 3 on the bottom. So I would like to factor out the 3 as well. But because we have the negative here, so I'm going to factor out a negative 1/3 right here. Right? And I know I cannot fit in everything on the same board, so I will have to erase this right here. We factor out negative 1/3, and then I will have the integral. Then we will just have negative, well, we'll just have x. Right? And then c is just 2, so we have x plus 2 over that x squared minus x plus 1 dx. But if I put down 2 right here, you see negative 1 times that is negative 1, negative 1 times 2. It's not that. This right here should have been negative 2. All right, so take a look first, right? So just plug in and then just work out the parentheses and work out the negative numbers. Just be really careful. If you multiply it in the negative 1/3 into here, you get that. If you multiply this into here, you get c being equal to that. So that's legitimate, right? So I cannot really fit in everything here. So let me see. Let me try. 1/3 and c is equal to 2/3. All right, so not so bad. If I'm taking a test, I can, do this one happily, but I won't be too happy of doing this one. But it's not so bad, right? Let me take a look. Anybody want to say anything on how we can do this one? That one's easy. How about this? So I'm looking at you guys. When I turn away, I'm just looking at the chart. So I want to see who can give us any suggestions for that. We cannot do long division because the top is degree 1, the bottom is degree 2. So long division cannot be done for this. U-substitution, it's not so, it will work, but it's not the best, I would say. And in order to do U-substitution, you actually have to break this apart into this integral and then the other integral. So not too ideal either. All right, this is what I would like to do. Have a look on the bottom. X squared minus x plus 1, right? I kind of have to take it back because we are still going to do U-substitution, not in the usual sense. We are going to do it this way. Check this out. On the bottom, let me just put a note right here. If we differentiate the denominator, x squared minus x plus 1, we get 2x minus 1. Nice. So, this is my favorite way to ask questions when we are solving hard equations or integrals. Wouldn't it be nice if the top right here is 2x minus 1? That would be so nice, isn't it? Because then we can just do a very easy u-substitution. So let's try to make that happen. Well, we need to have a 2x. We need to have a 2 right here. It's okay, just multiply this by 2. No, not really. We have to do the same for the whole thing. And this is not complete yet, because when you multiply the top by 2, make sure you divide by 2 as well. So we are going to do that. And you see, this right here on the top becomes what? 2x minus 4. But we want to have minus 1. Can we write it as minus 1 and then minus 3? Yes. Yes. Even though it's really strange, but it works. And if it works, we will be happy. That's the idea. So now, let's see. I'm just going to write that down. So this right here, ladies and gentlemen, I just want to get at least like the first part of the answer right. 1/3 natural log absolute value of x plus 1, done with the integration. Here we have the minus 1/6, right? And then let's put down a parentheses because we still have to break this down into two integrals. The first integral, I will put this down in blue. Integral 2x minus 1 over that for the denominator. Right, so that's the blue integral that we have. Next, we have the minus 3 inside of the parentheses, so it still is minus 3. And then we have the integral, and that for the bottom, so 1 over x squared minus x plus 1, and we have the dx here, right, parentheses. All right, this right here, again, we can do it pretty easily. This right here, we have to do the completing a square as well, just like what we did in the previous question. So let's just make it happen. Do it in red. This right here, have a look. This is the same as saying x squared minus x, and then take 1/2 of this, which is just negative 1/2. Square that is 1/4. So you want to see a 1/4 here. But originally, we have a plus 1. So this right here is technically, just break it down as 1/4 plus 3/4. This right here is a perfect square. What's the perfect square? X minus 1/2 square. And because you know we will be using the inverse tangent formula again, so we are going to put this inside as square root of 3 over 2 and then square. So this is the same as that. And again, you can just do u-sub in your head. U is equal to x minus 1/2, and dx is the same as du, so nothing too much to worry. So now, ladies and gentlemen, let's finish this right here. First one, we have 1/3 ln absolute value of x plus 1. Done. Next, distribute this so we get negative 1/6. This is in blue. It should be in blue. It's just going to be natural log of the bottom, which is x squared minus x plus 1. And the truth is, this right here is always positive. Thus, you can just put down a parentheses. And then, negative 1/3 times negative 3, we get plus. So I'm going to show you negative times negative is plus, like that. And then we have 1/2. So I will put that down right here. And then we have to do the integral of 1 over this guy times that guy plus that guy square, right? So the formula is 1 over this guy, which is the reciprocal of this, namely 2 over square root of 3. And then we multiply by the inverse tangent of the u is this, so I'll write that down, which is x minus 1/2. And then again, divided by a, which is that, so I will multiply by 2 over square root of 3. So that's what we have. And allow me to just cancel the 2 right here. That's plus 1 over square root of 3. And because we're all adults now, we don't have to rationalize the denominator. So we're just going to be done for this. All right. I'm pretty happy about fitting at least all the answers on the same line. So that's what we have, right? That's a pretty fun one. If you are taking Cal 2 though, this will be a really challenging one. And this is the one that you don't want to see on the test. We should just factor it out and do the partial fraction, right? Yes. But this one, I will say, is slightly easier than the one that we did earlier, but still pretty hard. Well, we'll see. You guys let me know if it's hard or easy. Anyway, first we are going to factor out an x from everybody. So we have x and then x to the third power plus x squared plus x plus 1. And then we can factor by grouping this and that. So you can see this is x. From here we can factor out x squared, and then we get x plus 1. From here we can factor out 1. So I'll put down plus 1, and then we still get the x plus 1. So we get x times, let's put down x plus 1 first, and then we have the x squared plus 1, like that. So again, partial fraction time, do it on the side and do it in blue, of course. Ladies and gentlemen, here we have 1 over x plus 1, x squared plus 1. All right, the first one is just x on the bottom. So we have some numbers, so let's put down a. Next, we have some constant over x plus 1. And lastly, we have a linear term because this is an irreducible quadratic. So cx plus d over x squared plus 1. Now, good news. Yes, a and b can be done with the carve-out method. So let's go ahead and do that. So that's a good news anyway. A equals when x is equal to 0. Cover up the same denominator. Put 0 in here and here. So we get 1 over 0 plus 1 times 0 squared plus 1. So this is just equal to 1. B, well, cover out the same denominator. X shall be negative 1. So let's write that down. And then we are going to put this in here and here. So we get 1 over negative 1 times negative 1 squared plus 1. And this is 2. 1 plus 1 is 2, and then times that, which is negative 1/2. I know, I don't know why every time I say 1 plus 1 is 2, and then people leaving a comment and people get really happy about that. Anyway, I didn't do anything wrong. 1 plus 1 is 2. Anyway, for C and D, let's just multiply all everybody by the common denominator. So we get 1 on the left-hand side. A is 1, so let's write that down. And the x will cancel, so we just have this times that. So it's x plus 1 times x squared plus 1, right? Next, x plus 1 will cancel. B is negative 1/2. So we have negative 1/2, and then we have x times x squared plus 1, like that. And then lastly, we have the plus cx plus d. X squared plus 1 will cancel, so we just have x times x plus 1. All right, and then just kind of simplify the right-hand side. So let's see, this right here is going to give us x third power and then plus x squared plus x plus 1. This right here is the same as saying x to the third power plus x, right? Yeah, and then just distribute the negative 1/2. So negative 1/2 x to the third power, and then negative 1/2 x. Next, you multiply this out, and this is really x squared plus x. So you do this times that, we get plus cx to the third power, and then cx squared, and then dx squared, and then lastly dx. Well, bad notation, but whatever. Yeah, we're not differentiating anything here, so anyway. All right, let's see. Well, let's collect the like terms for the coefficient of x to the third power, because there's nothing here, right? So here we see this is 1x to the third power, and then minus 1/2 x to the third power, and then plus cx to the third power. What that means is that we must have 1 minus 1/2 plus c. All this right here has to be equal to 0. Then we get c should be negative 1/2. Right? C should be negative 1/2. All right, and let's see, maybe let's do the constant term. So the constant term here, we have 1, and then doesn't really do us any good because we have 1 is equal to 1, so it didn't really do us any good. We have to have something that with d. So let's see, we are going to do this, plus x, and then minus 1/2 x, and then plus dx. So that's 1 minus 1/2, and then plus d. This right here is going to give us the coefficient of x, but there's nothing here, right? 0x. So this right here is equal to 0. And d is what? It's also equal to negative 1/2. Now, don't forget, we still have to go back there and do our integration. This right here, because the denominators are pretty nice, so we don't have to do anything too crazy. So that's why I said it's easier than the one that we did earlier. Anyway, first we have to integrate. A is equal to 1, so we just have 1 over x plus 1. So let's close that. Next, b is equal to negative 1/2. So I'm going to write down negative 1/2 here, integral, and then we have the 1 over x plus 1, right? And let's close that. Next, we have the cx, and that's ready as cx over that. Cx, c is equal to negative 1/2. So I'm going to have negative 1/2 integral, and then the x over that, so we have to put that inside of the integral. And lastly, we have d over that. D is equal to negative 1/2, so I'm going to write down negative 1/2, and then we have the integral 1 over x squared plus 1 dx. We are good to go. Let's just go ahead and integrate everybody. First one, natural log absolute value of x. Second one, minus 1/2. Again, natural log absolute value of this guy. Right? So again, this is negative 1 over 2 originally, but because you do the u-sub, you will be x squared plus 1. The derivative is 2x. So you need a 2 here. Be sure you divide it 2 right here as well. So this right here is actually negative 1 over 4. And then you have the ln x squared plus 1, and we just need the parentheses for that. Lastly, negative 1/2, and this guy is just inverse tangent of x. Very, very nice. All right. So you can see that a lot of the partial fractions questions is just that. Just do it. That's all.